and we're going to make a start. So, thank you very, very much for attending our workshop today, our webinar. As you can see, we've got iPad and the coding curriculum. We've got myself, Phil Sparrow, an Education Development Manager for KRCS. And then we've got with me Chris Smith, if he wants to say hello.
Hi, I'm Chris Smith. I'm the Apple Professional Learning Specialist for KRCS. Okay, so this is my iPad screen. I'm going to go to my programming window, collection of programming apps. We're not going to use all of these, but I'm just going to take you through a few. The one I'm going to start with is the BeeBot app. Now, lots of schools have a BeeBot, and if I was doing coding in school, I would start with real things. So if you start with a physical BeeBot or a physical BlueBot, if you've got one of those, that's the best way to start, by practically coding a physical object, or by doing coding type games. If you Google for coding without computers, you'll find lots of resources that'll help you get started with computational thinking that don't involve a computer or an iPad. But once you've done some practical activities, I would suggest a BeeBot is a good way to start. So I'm going to open up the BeeBot app. Hopefully it looks okay on screen. It's probably quite small. This is an app that only works in portrait mode. And you'll see it's got some different level activities. So I'm going to go to level 1. And this opens up and it gives me some instructions. So this is designed for Key Stage 1. Equally, if you've never done any coding whatsoever in Key Stage 2, even at Year 6, there's nothing wrong with starting at this level, but quickly progressing through. So here, I've got to get my BeeBot to move forward 1 space to a flower. And I tap on forward. It does put, we're going forward 1 in there. I press go, it gets to it, it says, congratulations, I've done a great job. I'm going to keep going with these. You'll see how they progress. So go to the next level. I can count the squares. So 1, 2, 3. We go 1, 2, 3, and go. So it's all pretty good. I'm putting some simple instructions in, and the BeeBot is doing exactly what I asked it to do. Now here, we go forwards, forwards. Then we've got to turn left and go forwards, forwards. Again, all pretty good. So far, so good. I'm going to skip to a higher level. So if I go to, I think level 5 might be the one. We'll have a look. So just something to be aware of when I've used this with children. When they get to this stage, they go forwards, forwards. Then we know you're going to turn left, and you count 1, 2, 3. So go forward, 1, 2, 3. Then we've got to turn left again. But at this point, often pupils use the down arrow to try and make the BeeBot come down to the flower. And when I press go on this, you'll see what happens. It goes along, looking good, going along great, looking good. Then he goes backwards 3 times and bumps into the edge. It doesn't actually complete. Now, the problem that I have with this app in terms of fully addressing the curriculum is we can't see the algorithm that we've written. So at the bottom of the screen, it says we've got 10 moves, but it doesn't tell me what those moves are. So it's very difficult to debug my algorithm. Great for practicing up, down, left, right, turning, those sort of things. So it's great for basic skills, but technically speaking, it's not covering what the curriculum wants us to do, which is write an algorithm, test it, debug it, and improve it until we get the perfect solution. So I just mentioned on here. So great starter app, but we need to think of ways to improve that. So that's how BeeBot works. There's lots of apps that do similar things, but BeeBot is free, which is always a great start for teachers. I'm going to go to another app by TTS called BlueBot, and you can get a BlueBot. You can see there's a little image of it here. It's exactly the same size as the BeeBot, but it's clear. It's a blue color, but it's also Bluetooth controllable. So that means you can have the physical movement of the BlueBot on the floor on a mat, and you can program it and see it work on the screen as well. Now, you'll notice here, I'll just go back to start. There's lots of different levels. I'm going to go to the explore mode and I'm going to do some basic programming with this. When you start up first time, it asks you to connect your BlueBot to it. Now, I'm not going to connect the BlueBot to this, so I can still use the app without having the physical BlueBot. And I'll show you how it works, how it's slightly one step on from the previous app. So you take the BlueBot and you put it onto the mat. There's various mats you can choose. You can make your own. And if you've got the physical BlueBots, you can purchase these mats or again make your own. So the real object moves in sync with the iPad. So you put a starting point. If my challenge to the pupils was to get to the red sphere over here, they would go to the program window and you'd count, you want to go 1, 2, 3 forward. So go 1, 2, 3. And you notice it's putting my code into the left-hand side of the screen. So then I want to turn to the left. So put that code into there. Then I can count across 1, 2, 3. Now imagine if I get this wrong. So I'll do 1, 2, 3 and go, now I'm going to try my code, see if it works. So I tap on to go. The BlueBot moves forwards, turns, moves forwards, but doesn't quite get to where I want it to go. So my algorithm isn't correct. Now I can check on the side here and go, we've gone forward 1, 2, 3, turn, then we've got 1, 2, 3. So check 1, 2, 3, turn, 1, 2, 3. So I needed that to be 4. So I can tap back onto the screen here, put the BeeBot back into its start position and add one more command. Try my code again. The BeeBot goes on the floor. The real one would be moving in sync at exactly the same time. And it gets to where I want them to go. So in that short sort of minute session there, I've written my algorithm. I've tested the algorithm. I've debugged it and corrected it, tested it again, and it's done what I need it to do. So that is the essence of the whole coding curriculum at a very basic level. But that would be a great start for anyone. And again, it's a free app and it's designed sort of key stage 1, early key stage 2. But if you've got no previous experience, it still works as a great app to get you started. That was BlueBot, and that just allows you to debug and see what you've done with your code. If I put too many of these in, I can drag these out and delete the commands as well. So it's completely editable. So I'm going to come out of this. I'm going to go to my next app just to show you one. This is one of my favorite apps. It's called LightBot Hour of Code. And when this opens up, you can choose, I think, the language you have in, but it says start and it shows me some different levels to work through. I'm going to go through each one really briefly. So the first one, the basics, I've only done 3 of those so far. There's some that are locked, but it says I need 3 commands to actually do this. And you'll notice it gives me a tutorial. The further you go on, the tutorial will disappear eventually. But it says, welcome to LightBot, tap to continue. I just keep tapping on the screen. It tells me what I've got to do. I'll whisk through these because I'm going to show you anyway. It's even got a hand explaining what it wants me to do. It wants me to tap onto the forward button, and that drops into my main programming window. I'll tap again. Okay, so I've gone forwards, and it wants me to the light bulb in, but I'm not going to because I want to show you here. If I run that code, it says retry, it's not working. And it's telling me to put the light bulb in. I could drag the light bulb, and if I put it in the wrong place, and we'll run the program, it comes along and says, no, you've still got it wrong. So I'm going to retry. And it's actually telling me what to do. I'm just going to drag this round to there, put the light bulb in, run again, and it says, congratulations, you can go on to the next activity. I'll do about 3 of these so you get the idea. So now it says, well done. Now here's some new commands, and it adds in a different block of code each time. So this time I've got to go forwards, turn left. Children find this easier because the LightBot is three-dimensional, and you can imagine you're the character, and you can imagine left and right more easily, in my experience, than you can with the BeeBot, where you're looking down in a plan view. So I put my code in, run the code, turns left, goes along, puts light on, congratulations. That's all fairly easy. And then you'll see, I'll tap through the instructions. It's added a spring in, and once you understand that the spring lets you jump forward, one you don't have to go up or forwards, it's all in one jump. Then we turn right, jump, turn right, jump, put the light on, and you see that sort of basic coding. So I'm going to go out of this and go back to the start and go to the next one, which is procedures. So this naturally moves you on through different levels of complexity. So here, I'm going to tap through these, so I'm going to explain this to you as you go along. We've got a main window and a procedure window. And if you try to put all of the commands into that main window, there's not enough space to put enough commands in to complete the task. So it forces you to use the procedure window. And I'll show you how this works. So procedure is a command that you can run multiple times. So in procedure 1, I'm going to tell the LightBot to go forwards, 1, 2, 3. So forwards, forwards, forwards. I want him then to put the light on and turn to the right. So that's my procedure. In the top main window now, I can say run procedure 1. So I'll run it. It goes along, turns on, turns around, but it's not complete because I need to run that procedure 3 times. So there you go, let's run that 3 times. And you see it completes the task, and let's move on to the next one. And they build up in complexity, and you notice the instruction didn't come at this time because it's given the instructions, you know what you're doing, and you just need to work out what goes into the procedure window and what goes into the main window. So again, nice gentle step through an introduction to a repeated pattern. It's almost like a loop, but loop's slightly different. This is a procedure. What I would say with this is if you work with a class, these are quite hard to do with the whole class because it's hard to monitor 30 children and where they are getting stuck or where they're up to with the app. They can work independently, but if you had the option to run in smaller groups, like a table group maybe of 6, I find that leading the first couple of activities with a group lets you identify who gets it really easily and who struggles with it. Then in following sessions, you might consider putting your making groups of or pairs of like ability pupils, because I find when you've got someone that's really good at it, they either dominate the iPad, do all the answers, and the other child doesn't get a look in, or they become frustrated by the child that needs to take longer and think about it for longer. But when they're working together at a likability, and I've done this with teachers as well, the conversations they have to solve the problems, that's the main point of doing coding, is to find a problem, discuss the solution, break it down to small parts, which is what a procedure is really, and come to a better understanding and come to the answer through dialogue with your partner. When left on your own, if you're good at it, it's really good. If you're not so good at it, it can be quite frustrating. So that was the second level of this, which was procedures. The next level is called loops. And I'll show you this first one. It only takes 4 commands to do this. Again, it's going to tell me all the answers, so you can read that. These are free apps, by the way, you can download from the App Store. So now, if you try to put all the commands in there into the main window, you can't because it's only got 1 space. So in the procedure, we need to tell the LightBot what to do. So I'm going to say go forwards, put on the light bulb. Now in the previous one, when we just did that sort of repeating pattern, we put program 1 into there and we put it in 3 times. Well, here we can only put it in once. So what I'm going to say is go forwards, put the light on, and then play program 1 again. I put that here, and you can see when I press this, you'll notice it will loop through this and go round and round. So it goes, it repeats the pattern over and over and over again. Now, I think technically in programming terms, they wouldn't like the fact that it just stopped there, because he would have walked off the edge of the building, because it doesn't say repeat a certain amount of times. But if you want something that happens constantly, this is a way you can do it with a loop. So like that, I can go to the next one. Again, it gets slightly more complicated. You've got jumps and things in there, but the same principles apply. So once you've taught the first element of this, you can then let children of the right ability work through it in a more independent way. So if you carry on with this, eventually, if the children and everything, you could go to code.org and you can print out certificates. You can maybe photograph those, put those into whatever you use to keep all the work, be it Seesaw or Shobi or Google Classroom, whatever. It'd have some evidence that they've done some coding. The other thing I would say with the iPad, if we'd done this coding activity here, so I'll just do it again because it's really quick. So in the procedure, we went forwards, light procedure 1, and in here we put run procedure 1. At this point, I might go to screen record, tap on screen record, run the code. It would make a video of that. That'd be perfect evidence to share with people. It shows their coding ability here, and it physically shows what happens, and it runs, and it's all working perfectly. So screen record on the iPad would be a great option there. Okay, I'm going to come out of LightBot and go to the next I want to show, which is Scratch Junior.
Chris?
So it's Scratch Junior, free app. You go to the home icon, and you'll see I've got some programs already there, some projects. Lots of schools use Scratch anyway. I'm going to make a new project. You see how the commands, they're similar in some ways, different other ways. So tap onto there, and it brings up my program window. You've got Scratch. I've been trying to do this with my mouse, but for some reason Scratch doesn't let me, so I'll do this with my finger. You'll see how it goes anyway. So I'm going to put Scratch down the corner of my screen, and across here you've got all these different commands that let you control Scratch. Scratch is the name of the cat, by the way. The very first one with Scratch originally, you see there's a flag at the top of the screen. That's how you ran the program. So you still have that over here. So I bring in the flag. I could have used this one where I tap on the character to start the program running, but I'll go with the flag because that's the traditional way it worked. I can then go to these blue section, and I'm going to go with the first one, which is the arrow moving forwards, and that would make Scratch move forward 1 space. I'm going to tap onto the 1, delete 1, and put 10 in there because I think that's a better amount. If I tap onto the flag, you see Scratch walks along. And if I tap on the arrow just to the left of the flag at the top, just up here, that will reset and get it back to the beginning. So I can move forwards, backwards, up, down, I can turn around, but I'm now going to go to this speech command, and I'm going to drag that in. Oh, sorry, I lied. I'm not going to go there. I'm going to this one, this speech command, tap it in there, and we can type in a phrase. Then I'm going to add in another little bit of moving forwards. Maybe we'll go 5. And I can put another speech bubble in, and let's go to the park. Let's have that. That's going to be the phrase I'm going to say. Now, when I run this, it'll go along, you'll stop, say hello, go a bit further, say let's go to the park, which is absolutely fine. What I'm going to now do, at the top of the screen, you'll notice you've got a picture icon. I tap onto there, and it comes with a range of backgrounds, but also you can take a picture, a real picture of your school or real setting, and put that in. But I'll just go with this suburbs picture. So that puts picture in. I'll reset it back to viewing, and we're ready to go. So we're sort of storytelling and coding at the same time. Now, what I need to do is I want to go to another scene. So I'm going to add a scene. I'm going to choose a different background, and I'm going to put a picture of the park into there. And I can put Scratch just at the edge as if he just walked into that scene. I'm going to put a flag to start. Again, you have to have the flag to start. Again, to move along, we'll go 10 again, because that's a good distance. And again, speak. Yeah, okay, okay. So, so here we are. Okay, so the last thing I need to do on the first screen, I need to tell it what to do at the end of the program. I can tell it to go to scene 2. So now I'm going to run my program. Goes along. He says hello. Says let's go to the park, and goes into the next scene. I've used this with year 3s doing a project on Egypt, and they put their own pictures of the pyramids in. They've done a guided tour of things. So it's a nice literacy activity and a coding activity. And I think the more you can link coding to other elements of your curriculum, the more engaging and the more successful it will be. So just 4 little apps. They're free, they get you started. And once you've done that sort of thing, you can move on to things that Phil is going to show you now.
Awesome. Thank you very much, Chris. I'm going to now move on and transition over to my iPad. So we're going to now look at 2 apps from myself that are a little bit more advanced and have some tools as well to support you with curriculum. So what we're going to do first is we're going to carry on with the language that the app Chris was using is known as block coding. So we speak in many languages. We speak in English, French, Spanish, whatever it might be. We speak in those languages. Those languages have components such as verbs, adjectives, nouns, and we use those components to create our language. It's the same thing in coding. We use components of coding language to create instructions, to create algorithms, to create procedures, which is what Chris is referring to. But we're going to look firstly at another block-based app, but something where you may have heard of, Sphero. So as you can see now on the screen, I'm now on the Sphero homepage. What I'm going to quickly zoom over to, because this is a bit more of a physical demo, you'll see on the screen now that we actually have a Sphero physically on the floor, connected. Okay. Now I'm very quickly going to connect to our little Sphero down there. It's going to make sure he's connected and he's happy. And then I'm just going to do what's known as orienting it. So yep, it says it's connected. I'm hoping it is. We're going to go on to one of my, I'm just going to try and control him right now. We're going to go and drive. And then I'm just going to aim it to make sure it's responding to me. It is. Okay, so I'm going to face him there. Perfect. So Sphero uses block coding. So I'm going to start a new program with my Sphero. We're going to go back to my main screen just so that we can see everything lovely and large. So again, you can see blocks at the bottom that are going to control the Sphero bot that I've got down. I've got a Sphero bolt with me today. The Sphero bolt is a larger Sphero that also has an LED display so you can make it shine and use graphics. So very simply, on start program, what do I want Sphero to do? I want it to roll. I'd like it to roll. I'm going to drag that up. I'm going to snap it on. I want it to roll. Ooh, there's some maths knowledge coming in here. Oh, look, degrees. They've got geography for headings. I want it to roll, we're going to say 90 degrees because I'm doing right angles in maths this week. At what speed? Let's go forward, definitely. We're going to say, oh, I don't know, we'll give it an experiment. We'll say 90 for the speed. How many seconds? 2 seconds. We'll say 2 seconds. Now let's go back to our Sphero. Let's see what that looks like. So I'm just going to hit start, and if it goes off the screen, I might be very upset, but we'll find out. So we're going to play. Look, there he goes. He's gone off the screen, but that's perfectly fine. I'll pick him up again in a minute. But you can see what it's done, and we've actually had a little feedback as well underneath, a little blue line drawn that shows exactly what the Sphero did, a bit of sensor data, if you will. Now, what can you do with this, you ask? Like, you know, okay, great. You've just drawn a line. You know, my children can draw lines. But there's a little bit more you can do with Sphero than just drawing lines. So let's have a look at some different code on the screen. So let's open up my Square program. Now, essentially, I've seen this, and this happened when I walked into a school. A child was doing a math lesson. They were doing triangles, so I've adapted what this child said to me using squares. I tripped over a Sphero in Birmingham, and the child said to me, "Oh, well, I finished my main activity of my learning, and now my teacher challenged me to draw a triangle with a Sphero." Now, what's that going to look like? So I'm now going to show you very briefly what this code looks like and how it draws a square. So bear with me. We're going to move the Sphero back into view on the camera. Just bear in mind I'm trying to make it appear. There we go. There he is. So when I was doing this, the words that Chris has mentioned already, such as debugging, so working out what the problem is, that will involve all this knowledge of headings, for example, for degrees, for cross-curricular activity. This will involve executive processing for children with special needs, so they have to put things in order. Logic, you know, problem solving for those higher order functions. That's what I need to do. I need to do aiming. I need to make sure that the Sphero's back end, if we will, is facing me, so the code executes itself properly. I'm just going to make it go over there a little bit, just in case. It might go off the screen. Let's hope he doesn't. So I'm going to press start. We're going to see what it does. Goes that way. It goes that way. Goes that way. And it goes that way. Amazing. It ran the code, and he's done a little celebration at the end. It does light up, but it's a bit bright in here, so you can't see all the lights it's doing. But now what I can do on my app, I'm going to go back to my app. On my app, I can actually look at the sensor data. So can you imagine with a child, if they were trying to draw a triangle, if we were trying to draw a right-angled triangle, what would this look like? Imagine if the triangle wasn't quite a right angle, or if you were saying, okay, I want you to, child, can we look in one of the corners? Are they acute? Are they obtuse? Can you imagine the cross-curricular activity we can have here? We've got orientation, got the gyroscope data, accelerometer to tell you how fast it's going. All this mathematical data that this is giving us that children could use in other lessons is fantastic. You can imagine we talk about averages here. There's so much we can talk about. And the Sphero just does this all on its own. This was a very quick show of Sphero, but the possibilities with these things are endless. What I also want to show you is that if you can't buy a Sphero, because we're showing you free things today, if you can't buy a Sphero, you can run a Sphero virtually. So I don't have a real Sphero, so I'm going to disconnect my Sphero. I've done a little program here. It's not going to make a square, but you could do this with your children virtually. So now it's going to play a simulation of what a Sphero would do. And again, it's doing exactly the same, although I've made it run slightly faster and to go slightly further. And it's then going to go to the right as well. So Sphero is accessible to you even if you don't have a pack of Spheros. It's a fantastic way to get into coding, but a little bit more for upper Key Stage 2. There are also Sphero apps for Key Stage 1 which go down into block coding. If you want to go even further up in the curriculum, so let's say we're talking about children who are starting to learn languages that aren't block coding, for example, if we're talking JavaScript or Python, I can actually, for example, view my code in JavaScript. And here you can see, although this looks like, let's be real, it looks like a lot of gobbledygook to most of us. This is like we have nouns, verbs, and adjectives in our language. This is the nouns, verbs, and adjectives, but in code. Okay? So if the coding, for making apps work, for making most of the things we use in our lives work, and this is what will entice children into coding, is knowing that the language you're speaking in our coding lessons are what program most of the things around you. So that's a physical coding product. I'm going to go now for our last part of this webinar, and I'm going to try and finish at 4:45. I apologize if I don't. I'm going to go as swiftly as I can, no pun intended. We're going to look at Swift Playgrounds. Now, Swift Playgrounds, is Apple's own offering to the coding curriculum, and where I take a lot of my inspiration from. So they offer these books, the Everyone Can Code books, and think of this as your medium-term planning, if you will. They introduce you to what Sphero is. They say, what Swift is. Look, this is what Swift is. It's a programming language like we've spoken about before. French, Spanish, Swift, Python, Java. They're all languages. It tells you a bit about Swift Playgrounds and what it is. But the main thing I want to show you about how this is the teacher guide. It tells you about the lessons. It breaks it down into their components: learn and try, apply, connect. So you can see how these are very familiar medium-term planning sort of terms you might see when you're reading some frameworks that you've bought into, for example. But it gives you here a pacing guide on how many lessons or how many classes you should be doing certain parts of the program for. So you can go through these free guides from Apple, the Everyone Can Code series, and they really have got this in mind with how would a teacher actually teach these, and it helps you with pacing and key terms. What I'm going to show you now on my iPad is your first maybe it might be your first half hour of your PPA. It might be your first lesson with your class and how easy it is to get started. I've downloaded Swift Playgrounds. I'm going to tap it. It's blank right now. In the bottom, I've got Learn to Code 1. I'm tapping it. It's adding it to my library. This isn't one lesson. This is one unit. I'm going to do Learn to Code 2 because that might be the unit we do after we're finished. They are downloading live. They won't take very long. I'm actually going to stop Learn to Code 2 because I don't need my iPad downloading 2 things at once. But I'm downloading an entire unit, and that is not going to take very long. And we could even get this loaded beforehand if we wanted to. But Learn to Code 1 is here. Don't worry, I had planned it for it to do this because I wanted to show just how quickly it happens, and it does. It's new. We're going to open it, and this is going to be the experience you have with your class when you do Swift coding. Opening it up, it shows you the chapters. So this is not one lesson. This is a unit. And that pacing guide I showed you about earlier will say to you how long you spend on commands. So it says 3 lessons on this unit, another 3 lessons on functions. But I'm just going to go to the introduction, and I'm going to tap off because it's just loading introductions. It gives everybody, this is you and your students, a short prompt. I call this the context. For example, when we're talking to children about money, we say to them, well, we need to learn about money because we buy food from the shops. And children go, oh, yeah, of course, we need to know that. So these little Learn to Code slides at the start give us the context of what we're learning. So we're learning about commands. No, wrong one, sorry. I do apologize. Let it load again. Give it a second because there are a couple more slides there. We're learning about commands, and it will tell us what commands are once it's loaded. Technology. Here we go. Right, so commands. Have you ever followed a recipe to bake something delicious? Or followed some instructions to assemble something cool? You need to follow the instructions in the correct order, or something unexpected will happen. Writing code allows you to create your own set of instructions for your device to carry out. Your goal is to figure out the instructions, in which order, and how they'll result in something great. You'll start by writing a command, and Chris has spoken about this language earlier. It shows our contextual example underneath. It shows the piece of language, move forward, open bracket, close bracket, which is saying start and close the command, the part of the sentence. Shows what it does. Collect gem, to collect a gem. These are the elements, the commands that make things, these are the commands that make things happen. They're almost like verbs, if you will. Okay? And it says here, look, notice the mashed together words. Code is punctuated and spaced like human languages, but commands have spaces between words, no spaces between words. Commands always end with parenthesis. You'll see why later. So you can see all this contextual. These are all talking points for you in your class when you're actually teaching. Now, this is an actual piece of a lesson you can actually do with your children. So on the right, it's going to load a nice graphic. It looks a bit like a video game. I'm a gamer myself. But this loads up a video game, and this is going to show what your children will experience. There are many things you can do to make this accessible to children with special needs. If I had more time, I could show you things that help it read the screen aloud for us, for example. Could do that. But right now, it tells us on the left what we've got to do. Our goal is to use Swift commands, or our Swift coding language, to tell Byte to move and collect a gem. Your character Byte loves to collect gems. It's similar to LightBot. We need to make LightBot move and light up on a certain spot. We need Byte to move. Now, basically, I'm going to move forward slightly. I need to tap to enter some code. I can type with my fingers if I wanted to, but you'll see at the bottom, you may not see at the bottom, you might just have to move. I have some options at the bottom where I can essentially just tap to enter things rather than type. So I'm going to tap because I can see if I zoom in, he needs to move forward once, move forward twice, move forward 3 times, and then collect the gem. Let's run my code and see what happens. But you can see how Swift is introducing key terms. It's giving you that medium-term planning. It's giving you progression. Children could record the screen and give you feedback. This would be your marking. This would be your evidence. So you can see, congratulations, you've written your first lines of code. This is a real sense of achievement. Children are actually becoming coders. You can tell children that Swift is the language used to make apps on iPad and iPhone and Mac. This is a language that's used in real life to make real things that children would be very enthused about. It will then move on to the next lesson, adding a new command. So we're going to make Byte do something new today. Now, what I'm going to do, we've seen the idea of Swift Playgrounds. We do have tap to enter code. I'm going to show you very quickly what happens when we go wrong. I'm just going to make Byte move forward lots. And you'll see what's going wrong, and we'll talk about and you'll see about Chris's debugging process again. So he's going to move forward. He's just smacking into the wall. You know, that's a problem a child's got to solve. So I might go back through my code and go, how many times does he need to move forward? 1, 2. Okay, I'm going to delete some code. I'm going to delete some code, and then I'm going to go back. So let's delete. I only need him to move forward twice. Now I need him to turn left, and then move forward again, collect the gem. That's a standard debug process, and that would make this code run properly. Okay, so you can see how Swift goes through lessons. There's lots of progression, and you can go through lessons and lessons and lessons of this. I want to show you before we finish with Swift. I apologize, that was a very quick one. We actually have a clip. I want a clip to show you before we finish, and this is our last thing, of an actual child in an actual school giving her teacher some feedback of a lesson that she did with Swift Playgrounds. So you'll see here on Twitter, we've got a teacher, Mrs. Walker Teach, at Snenton Primary, and her child Antonia in her class. We've got permission to use this clip, and we're allowed to say her name. We've got permission from Mum. So the audio will hopefully come out, and you're going to see this is actually Antonia's work and her talking about her own debugging process.
I was struggling with this particular command because here I was going to do get the gem and then do a 360-degree turn to go to the blue route. So I would end up here at this blue spot here. But then I realized if I go to the green route, if I go to the green, which is here, I'll be able to go closer to the toggle box, which is here. That would be leading me there. So the green route is fastest rather than doing the blue route, as it would take many.
So that's just
struggling with this.
That is just a clip, and this is during commands as well. This is during the first section of Swift Playgrounds, and you can see that Rachel Walker is going to get a lot of feedback from her student there at Snedton, and you can only imagine what she's going to do as she goes on in her journey. So I just wanted to show that and sort of showcase Antonia's work, because I saw that on Twitter the other day, and I was just like, I just said to myself, that's perfect. I'm talking about that soon. It shows exactly a real school, a real student doing this and showing it's achievable, and that the evidence is there and it's recorded and it's usable, and this is all free and accessible to you. Now, we're going to go back to finish up for today on this stream. So thank you very much for joining us. All I want you to think about is if you've got any questions or answers, you can email us at edsales@krcs.co.uk. If you've got any next steps of what you're going to do. Your next steps, if you were wanting to talk to KRCS again in the future, we can offer planning essentials, curriculum essentials, and technical essentials to yourselves, and you can see the descriptions of those on the screen. We can come in and run some leadership workshops with yourselves to help you guys think through a project where you want to implement more iPad, more Mac, in your schools, and how that's going to work with curriculum, how is that going to work with finance, so on and so forth. It might be that you need to check that you're technically ready to put more equipment into your environment, and that you need one of us to come out and check that your infrastructure can handle it. We're here to support schools every step of the way with iPad and Mac, regardless of whether it's your first or your 1,000th device in your school. We support many schools across the country. I hope you've enjoyed our little whistle-stop tour of coding with iPad and how you can get started. Hopefully there's been some things that you can take away from this stream. I've really enjoyed presenting to yourselves, and I'm sure Chris did as well. That is the end of our stream for now. As you can see, any questions, talk to us at edsales@krcs.co.uk. I'm just going to put the music back on for a few minutes, and if so, you can write down that email, and if you've got any questions. But otherwise, it's been absolutely wonderful to speak to you, and we will hopefully see you in our next stream.